Okay, last time around we talked about frequency distributions. Today we are going to talk about relative frequency distributions. Okay, so relative frequency distributions. So last time around you built a table. Okay, so let's give an example table. And what you did is you had two parts to the table. You had like IQ scores, and we had driven those into classes. So we said that there would be 50 to 69 and 70 to 89 and 90 to 109, 110 to 129, and like 130 to 149. Right, and what we did is over here we gave frequencies. So today what I'm going to do is I'm going to give a relative frequency. And now you may be asking yourself, what is a relative frequency? Well, a relative frequency is not so much how many in the population are in that class, but what percentage of the population is in that class. So kind of backtracking from the table I had before, approximately 2.6% of the population is in this class. 42.3% of the population is here. 44.9% of the population is there. 9% of the population is here. And 1.3% of the population is here. Now, if you think about this table, it's giving you a lot of the characteristics of the data. Like, you know that the center is somewhere around 100. You know that the values are ranging somewhere between 50 and 150. You know that they're distributed more compactly in the middle than they are at the edges. It doesn't seem like there's a whole lot of outliers here. But there's a lot of information that you can get straight from this table. Now, we don't know from this table like how many people are in the data set. We know what portion of the people fall these ways. But I don't know if this is like a data set of 1,000 people or 2,000. So I do lose some information, but it makes things work. Now you might be noticing something. Okay, so if I add these numbers up, right? So if I add up 2.6 plus 42.3 plus 44.9 plus 9.0 plus 1.3, I end up with 100.1%. So that seems a little off. Ideally, the relative frequencies should sum to 100%. Why am I getting this? Because these numbers are, if I actually worked it out, there'd be much more digits than just one. So these have been rounded. So when you're rounding, there's a chance that you're going to be a little bit off on some of them, right? And when they add up, we might get a number somewhere between 99 and 101. And it's perfectly okay if the sum of these things is somewhere between those, because that reflects that, yeah, there's a little bit of rounding error, but if you get below 99 or above 101, we've got a problem. Okay, so one of the ways that you could check if you did the relative frequencies correctly is to say, hey, did I get a number that's really close to 100 and at least between 99 and 101? Okay, so in summary, a relative frequency table is a table that summarizes your data using percentages. And those percentages should sum to something really, really, really close to 100.